Okay, this problem is 1762 buildings with an ocean view. Medium difficulty if there's n buildings in a line. You're given an integer array height of size n that represents the heights of the buildings in a line. Ocean is to the right of the buildings. A building has an ocean view if the building can see the ocean without obstructions. Formally, a building has an ocean view if all the buildings to its right have a smaller height. The term list of indices of buildings that have an ocean view sorted in increasing order. Okay, so here you got heights 4231 023. Building 1 0 indexed does not have an ocean view because building 2 is taller. Building 1. Oh, okay, so that's this one here. Yeah, so basically the 1 has nothing to its right, so that's why you can see the ocean. 3 is taller than 1, so you can see the ocean. 2 is smaller than the 3, so that's why you can't see it. And the 4 is bigger than everything to its right, so that's why you can see the ocean. And here, every number is bigger than all the elements to its right. So 2 is bigger than the 1, 3 is bigger than the 2, 1, and so on. So that's why all of them are here. Here, only 4. 4 is the tallest, so everything to its left is smaller. So that's why only 4 has, which is index 3, has the ocean view. Okay, so we can also maybe visualize this to make this more clear. So for this example here, we got heights equals 4231. So you got, so basically, if this is the, if you're looking at this vertically, it kind of looks like this. Right, so this would be like height 0. This is height 1, height 2, height 3, height 4. So you can see 1 has nothing blocking it. 3, the only thing to its right is the 1, so you can see through. The 2 is blocked by this 3 right here. So that's why it can't see to its right. And at 4, it can see all the way through, nothing's blocking it. So that's why all the indexes will be included except for building 2. And building 2 has index. So if you look at the index, this would be 0, 1, 2, and 3. So that's why here building with index 1 is excluded. So then that's why you return 0, 2, 3 here. So basically, so we can write an algorithm for this is we would go from the right and then go towards the left. So we would do like for I in range, length of heights, -1, and then -1, -1. So that would iterate from here to the end of the list, then you go here, then here, then here, and then finally at the 0 index. And then as you're doing it, you would keep track of the max height that has been acquired so far. So if you're doing here, heights equals 1, 3, 2, 4. So 0, 1, 2, 3. So this is height 1. Height 3. Height 2. And then height 4. So 4 is the max height so far. So that would be here. Then you go to this 2. 2 is less than heights of I. Because 2 is less than max height, so skip. So don't include. Then you go to this one. Index 1, height 3, less than max height of 4, so you don't include it. And same with the one here. Whereas here, index 1, max height is 4, or 1. Then we go to this 2 here. 3, 3 greater than, so here max height is 1, greater than max h is 1, implies include and set max height equals 3. Then then you go to index 1, which is the building with height 2 less than max height, and then 4 would be bigger than the max height. Okay, so I think we can start coding this now. First we'll set max height equals, what is the height value? So it's always going to be greater than equal to 1. So we could set this to 0, and then if heights of I greater than max height, then you set max height equals to it, and we would have this list here. It's going to be sorted in increasing order, so then we could append, since we're iterating through the index from largest to smallest, we could have a list where we append the indices always to the left, or we could just or it would be in from order from largest to smallest, and then we would reverse it. So I think we could just, yeah, we could just use a list here, and then we'll just append the indices, and then you return you will return it in reverse order. So if heights of I greater than max height, then height equals to heights of I, and then you append the index, and then that's basically it. Because it says here, yeah, if all of those students are going to have a smaller height. Yeah, so I think this should work. And it passes all test cases. So yeah, thanks so much for watching this video.